Hello guys, let's solve another LeetCode problem, 70 climbing stairs. It's an easy problem and we are trying to solve the blind 75 list, and climbing stairs is one of the first problem in the dynamic programming. I already made a video about how to approach dynamic programming problems. I will link into the description below. Please watch that video first if you are not sure how to approach dynamic programming problem. And you can come back to this problem. For this problem, so you're climbing a staircase, it takes n steps to reach the top, right? And each time you can either climb 1 or 2 steps. So basically, you have something like a climb. You want to climb a staircase. And so you are here. And each time you can climb either 1 steps or 2 steps, right? So either you can climb to 1 step from here, or actually you can go to 2 steps together. We have to figure out how many distinct ways you can climb to the top. If you already solved Fibonacci problem, this is one of the variation of that problem. So let's talk about what is the input and output test cases, right? So let's write it down right first. So for this input, I want this output, right? So what is your n? So if your n is starting with, so the lowest value of n, you can look at the constraint, this is 1, right? So for 1, if you have only 1 stair, you can go up only one way. So the result should be 1, right? So now you have 2 stairs. What will be the result? So for 2 stairs, you can either go 1 step and 1 step. There is 1 ways, or you can directly go to the 2 steps, right? So for 2, you have your result is 2. And if you look at the example 2, you'll see actually for 3, the result is 3, right? And these are the examples, so you can take a look at this one. So for 3, your output is 3. And if you want to keep going, you can go from 4, 5, 6. But for each step, what you can do actually, you can take the n-1 steps. So if your fn is the function, recurrence function, so fn, what you can do actually, you need to figure out how you can do n-1 steps, right? That's one way to do it. And then you take the 1 steps remaining. Or what you can do, you can find out actually how can go into you n-2 and then take the 2 steps, right? So that means if you need actually, for example, f9, you need to find out f8. That means you can take up f8 if you know actually how to calculate f8. And basically, or you need to do f7. If you sum these two up, that becomes actually the result for f9. So if you can come up with these recurrence relation, that's pretty much it. You are done with the problem. You can just write the code for it. The important part is actually you need to know actually what is the base case, right? So if you know the base case, then you are good to go. So there are 2 things is important. So number 1, what is the base case? And number 2, actually come up with this recurrence relation. So we'll use dynamic programming bottom-up approach. So if your n is less than or 3, right? So for each of them, you just want to return n. Because for n1, you return 1, for 2, 2, and 3, and 3, right? And n is always as positive number in the constraint section, you can see. Then we will store, we'll keep track of in a list. So basically for dp as an list, just initialize all this value with 1. Then for each of the values, what you want to do is starting from your dp1 is 1, and you want to do dp1 as basically 2, right? So all of them starting with 1, and then dp1 is 2, and then you want to calculate from 2 to n. For each of the values, you want to calculate dpi, which is dp I minus 1 plus I minus 2. And finally, you want to return just dp n minus 1. Yeah, that should be it. So your first location dp0 stores the value for 1. Second location dp1 store the values for 2. This is 2. And for each of the other things from 2 to continue going for the index, you will keep actually adding the values from previous 2. Yeah. That's pretty much it. Thanks for watching. I will see you in the next dynamic programming problem for LeetCode.